So we're going to talk about the equality of surds, and essentially if I have two surds that are equal to each other and their square root is the same. So if you look at this part, a plus b square root n is equals to p plus q square root n, so square root n is the same, right? And if they are equal to each other, we can simply say that a is equals to p and b is equals to q. To really kind of see how does this work is a question over here. Given that a minus 5 square root 3 is equal to 7 plus b square root 3, with the surds being the same, so we can straight away say that a is equals to 7 and b is equals to negative 5, because when surds are equal and they have the same surds form over there, when you make the surd form the same, they are just equal. Okay, it's just equality of it. So we'll kind of jump over to a question like that where I'm given this, and we're going to try to use star to solve them. And the first part is to really search the question. So I'm given an equation here to read the problem, right? Search is to read the problem. Given a equation here of two sets, so I have p plus q squared root 5, but I square the whole thing is equals to 29 minus 12 square root 5. And we are given that p and q are rational numbers. Okay, p and q must be rational numbers. If they're not rational, then it's not possible. We're going to find the possible pairs of the values of p and q. So to kind of like note this down, okay, I'm given a equation where the left hand side of the is a surd, but there's a square to the surd, while the right hand side doesn't have a square to the surd, right? So in fact, my goal is to make this guy over here, so just do some rough work over here, equals to 29 minus 12 square root 5. I need to make the right hand side similar to the right hand side. Sorry, the left hand side must be similar. So the goal is to convert this guy to make it look similar, and then I can compare p and q with, or whatever I have, with the right hand side thing. So what I'm going to start, and then that will give me p and q. So I'm going to start with the left hand side, which is simply p plus q square root 5 bracket square. Okay, you cannot actually just compare now, is because of this square over there, because if you do that, it doesn't really make sense. And if you apply your unique identity of a plus b bracket square, you'll get p square plus 2pq square root 5. Okay, and this is plus q square root 5 square, and then you will have p square plus 2pq square root 5 plus 5q square. So the equation here is p plus q square root 5 bracket square, it's equals to 29 minus 12 square root 5. With this, since I found a simplified form for that, 2pq square root 5 plus 5q square, okay, is equals to 29 minus 12 square root 5. We're going to compare the surds form and the rational numbers, p square and 5, and since p and q are rational numbers, this would mean p square and 5q square are rational numbers. So if I write it in this way, we can actually see here that oh, I forgot the 5p square. Just write the 5 out. Okay, we can actually see that this guy is equal to 29 and 2pq is equals to negative 12. So we can form a relationship. So from comparing the surds, we can deduce that p square plus 5q square is equals to 29, and then we have 2pq is equals to negative 12, and hence we have pq equals to negative 6, p is equals to negative 6 over q. So what we have here is that we are going to use simultaneous equations. Okay, but this simultaneous is going to be a bit tricky because you have quite a lot of things to do. So let's start on it. Equation 1 and equation 2. Okay, so we're going to sub 2 into 1, and that will simply give us over here will be negative 6 over q square plus 5q square equals to 29, and subsequently you have 36 over q square plus 5q square equals 29. Not going to be easy here, so it will be 36 plus 5 q to the power of 4 divided by q square equals to 29, and we can kind of move things along the way. We will have 36 plus 5q to the power of 4 equals to 29q square. Kind of make this into an equation with one side 0. So we have 5 to the power times q to the power of 4 minus 29q square plus 36 equals to 0. Seems quite unsolvable. You have not learned how to solve anything higher than the power of 2. But in fact, I will just show you a little trick to this whole thing. I'm going to let x be equals to q to the power 2. So let's write this expression in terms of this way, right? Can I write this guy as 5 times q squared to the square minus 29q square? Okay, just q square, right? So I don't have to do it. Essentially, I can actually write this as a quadratic equation. So if x is equals to q square, shouldn't it just be 5x square minus 29x plus 36 equals 0? Can you see it becomes a quadratic equation here in terms of q square, not really in terms of x. So I kind of like make it like a kind of like inserted quadratic equation here, and this can be factorized. So we have 5x minus 9 times x minus 4 is equals to 0. So this would mean that my equation over here can be written as 5q square minus 9q minus 4. Okay, this is pretty tough because not many students can see that there's a hidden quadratic expression, but not in terms of x, but now in terms of q square. So with this, we can actually kind of solve it. So q square is using the product law, right? Zero product law. 5q square minus 9 equals 0. Or sorry, this should be q square. Or q square minus 4 equals to 0. And from here, we can figure out that q square is equals to 9 over 5. And q is equals to plus minus 3 over square root of 5. Okay, you can actually just simply do this and you will get this. While the other side is q square equals to 4. Q is equals to plus minus 2. Now, at this stage, what you're going to do is you're going to look back at the question. Remember, q must be a rational number. So since q is a rational number, you're going to reject the irrational one. So we're going to reject, write a reason as q is rational. So the only answers available here is q equals to plus minus 2. So what you're going to do here is you're going to now sub q equals to plus minus 2 into p equals to negative 6 over q. So when so the first one is p equals to negative 6 divided by positive 2, you'll get negative 3. And or when p is equals to when q is equals to negative 2, p is equals to positive 3. So therefore, p equals to negative 3, q equals to positive 2, or p equals to positive 3, and q equals to negative 2. A pretty long question, but the idea so there are actually a few main ideas here. One is you make the left hand side of the surd, the unknown one that you're trying to find, to look similar to the right hand side. Okay, which is the first step here. This is the first step here, and then the second step is to do your simultaneous equations. And this is a bit tougher because right now you have a quadratic equation. Okay, so this is a quadratic equation, not in terms of x, but in terms of x to the in terms of q square. That means now your variable is q square. You're going to treat q square as like x. So I've shown it at the side here. And then you must learn how to reject it based on the question. So you need to read back. Now, so we have done the STA part. So we have translated and we have answered. The last part is to review. How do you review these questions? All you need to do very simply is to plug these values into here to see if they're equal to 29 and see whether this is equal to negative 12. And that's about it for solving such complicated problems for equality of surds. Yep, so that will be all. See ya.